Okay, so yeah, what we're gonna talk about is about the server client discovery or discovery service we have at Fast DDS, which is an alternative for node discovery mechanisms in ROS2. For that, I'm afraid I'm gonna have to talk about some how the middleware works. So maybe that's a bit dry for you, but I think it's really relevant for the ROS2 community right now, this talk. So we'll explain a bit how the simple discovery protocol works, which is the default DDS discovery protocol, is the one defined on the standard. And then I'll explain or I'll give you an overview of how the server client discovery is architecture. And then we'll do some, how to configure a node, and then a small experiment to see some performance between the two. Okay, first of all, what is DDS? DDS is the acronym for Data Distribution Service. That's the as the object management group, which are the guys doing this standard, say. This data distribution service for real-time systems is the first open international middleware standard directly addressing the public subscribed communication for real-time and embedded systems. It introduces a virtual global data space where applications can share information by simply reading and writing data objects addressed by the means of an application-defined name, which is called topic. And this probably rings a bell because it's the same terminology used in ROS1 and now in ROS2, because we're using DDS in ROS2. We have publishers, we have subscribers or subscriptions, or they are calling ROS, and we have topics, right? The basic architecture or an overview of the DDS standard is can be seen in this figure. We have several participants. In ROS, these guys will be nodes, and then they have publishers and subscribers, maybe only one of them, maybe a few of them, doesn't really matter. And then they can discover each other, and if a publisher and a subscriber share a topic, then they can just, the publisher can start sending data to the subscriber right away. So what we're going to talk about is how this connection between the publisher and the subscriber is done and how it can be improved in some scenarios in ROS2. First of all, why DDS? We had some discovery mechanism in ROS1. Well, first of all, DDS has the same architecture as the ROS1 discovery, so it was really easy to make the switch and to not change the paradigm for the community, because they were already familiar with these publications as subscriptions. There is one very important change, though. It's that the DDS presents a distributed system, meaning that there is no one in charge of the discovery. In DDS, the participants are dynamically discovered. So we eliminate the single point of failure that ROS master is. If in ROS1, if the master application dies for whatever reason, then newcomers will not have discovery. This is not the case with DDS, because newcomers will still be able to discover the other guys. So a quick overview about the simple discovery protocol, which is the default one in DDS and therefore is the default one on ROS2. It's called the simple discovery protocol, and it's divided in two phases. The first one is called participant discovery phase. That's when when the nodes or participants discover each other. This is the part that is done like dynamically. It's done using multicast communication. So every participant, this guy and that guy, they are writing they're sending and listening for discovery traffic in a well-known multicast address. So this guy only needs to send one packet to that multicast address, and that gets received by all the other ones. And the same way, if another guy writes to that multicast address, then participant one will receive that information. And they don't know where each other are. They only know the multicast address they are using, right? So in that way, they discover each other dynamically. Once they have done that, once every node knows each other, then they start what is called the endpoint discovery phase, which is when they start to share information about their data readers and data writers, which they are calling DDS. That